Okay, these are notes on section 1.8. We are solving absolute value equations and inequalities. So these are equations and inequalities that involve absolute value. So sort of how are we going to write these solutions out is kind of what we're looking at on this table. So the first case, when we have an absolute value is equal to some constant value, then we know that the absolute value of x x can take on either a value of k or negative k. Because we take the absolute value, it's really like squaring and then taking the square root. So essentially you get rid of the negative. So the solution set here, we're going to write this using the little wavy brackets. This is sort of the fancy way of writing it. You could certainly write it out like this, writing the x is equal to k or negative k. But we can also write it as negative k and then comma k. Kind of looks like an ordered pair, but it's not. It's the solution set. How do we graph this? Well, we're just going to put two dots, right, on at negative k and k. Okay. So that's not very interesting, but it gets a little bit more interesting when we look at absolute values. So if the absolute value of x is less than k, so that means, what do we got? We've got x is either greater than negative k or x is less than k. So we think about this. I put the negative first, but really when you think about it is, how do you solve this thing? You say x is less than k. That's this one here. And then you do the opposite the opposite inequality and the opposite of k. So we change the direction of the inequality and the sign of the number, and that gives us that x is greater than negative k. All right, so now that is what we get from this, but now how are we going to write that? So think about interval notation. So we're going to be above k, negative k, but below positive k. So that's going to not inclusive, exclusive, negative k to k, okay? And, we could do either an open circle or parentheses and then shade between, okay? That's how so those are parentheses because we're exclusive of those two values. Now, what if it was less than or equal to? So it's very similar, only we're going to get inclusive of negative k and k. And so then we'll use little brackets, square brackets, or if you're going to use, closed circle would be another way that you've seen it. But we're going to try to get to the idea of brackets and parentheses here. All right, now greater than. So think about it. We're going to write exactly what it is. X is greater than k, and then change the direction and the sign. So x is less than negative k. So in this case, how do we write it as an interval notation? Well, we go from negative infinity up to, but not including k, or then we do, I'm sort of running out of room here, I wrote too big, positive k to infinity, all right? And then, so that's going to be parenthesis going to the left, shading to the left, parentheses at k to the right, and going to the right. Okay, so parentheses or open circles is kind of how you used to be able to do that. All right, and then, and equal to, so now we're going to still have negative infinity up to negative k, but it's inclusive, and then inclusive of k, and then to positive infinity. And so similar thing, what we saw up above, except now we'll use square brackets and shading to the right, square bracket, and I'm sorry, shading to the left here and shading to the right here, okay, from square brackets at negative k and k. All right, so let's try solving an equation. So A here, we have the absolute value, 9 minus 4k is equal to 7. So if we needed to, we would isolate the absolute value. So if there's like a number in front, we would divide by it. Or if there's a plus something, we would get it to the other side. Get the absolute value by itself. All right, now this one's already there, so we're good. So now we're ready to break it into two problems. So we write it exactly as it is without the absolute value. So we do 9 minus 4x equals 7. This stuff in here can either equal 7 or it could equal negative 7. So 9 minus 4x equals negative 7. Because if this stuff in here is equal to 7, it works. If the stuff in here is equal to negative 7, the absolute value of negative 7 is 7, so it would work as well. And now we just solve these two equations. So let's see, take the 9 over, so we get negative 4x is equal to negative 2. X equals 1/2. And what happens over here, we take the 9 to the other side. Negative 4x equals what? Negative 16. And divide both sides by negative 4. So x is equal to 4. So x is equal to 4. Or it's equal to 1/2. So we could use this notation up here and say, in a solution set, 1/2 and 4. That works. Okay. All right. Now this one here is using this idea. We kind of skipped over it up here. This note that if absolute value of A is equal to the absolute value of B, then A and B must either be equivalent in value or opposite in value. So in other words, if absolute value of A is equal to the absolute value of B, then either A is equal to B or A is equal to negative B. All right. Now, I suppose you could also say, oh, well, negative A equals B is also an option. Well, it's that's the same as what we wrote here, right? And negative A equals negative B. Well, that's really the same as this. So we don't write all 4 possibilities. We really just write the 2 because that's all we really need. This is equivalent to this. This is equivalent to this. So we don't write all 4. We just write the 2. And so what we'll do is we'll say 3x plus 2 equals x minus 5. So that's got to be true. Or 3x plus 2. And then I'm just going to make this second one negative x plus 5. Okay, so those are the 2 possibilities. Let's solve this one. Bring the x over, so subtract x, that's 2x. Subtract 2 from both sides, so that's going to be negative 7. So x is equal to negative 7/2. And same thing here. I'm going to bring the x over. That gives us 4x this time. And bring that over. That's 3. Subtract 2 from both sides. And then x equals 3/4. So those are our 2 solutions. Again, you could write them in using this solution set if you want to. All right, now let's talk about inequalities. So the inequalities, we want to, again, isolate the absolute value. It's already isolated for us. So we're going to now break it into 2 inequalities. So the first one, 4x minus 6 is less than 10. And then we want 4x minus 6. We change the direction of the inequality, greater than, and we change the sign of the number. So greater than negative 10. All right. And also you probably notice, if you think about it up here, when we have less than and less than, we have ands in there. When we have greater than, we have ors in there. You may not have noticed that, but that's a good thing to kind of remember. So we have less than 10 away. So that's kind of contained within. So when we have an and, from absolute value inequalities, it's going to be shading between them. When we have ors, we're shading outside certain boundaries. All right, so we're going to notice that as well. So here, I'm going to include the word and in here, right? Because it's this and this at the same time. All right, so let's solve this. Move this 6 over, so we get 4x is less than 16. X is less than 4. And we have move the 6 over again. We get 4x is greater than negative 4. We added 6 to both sides. And so finally, x is greater than negative 1. So when we solve solve the inequality, we get this. If we wanted to write it as an interval notation, which is kind of what we want, x is greater than -1, but less than 4. So we have -1, comma, 4. So this looks like an ordered pair, but not. Remember, it's interval notation. It's between -1 and 4, but exclusive of those because we're not including the equal sign. If we wanted to graph that, we could graph it too. We have -1, we have 4, we have parentheses, shading between. So it doesn't say to graph this per se, but sometimes it's helped to visualize that too. Oh, sorry, that's a -1. So -1 to 4, exclusive. Okay, now it's greater than. It's also equal to. Notice this is not equal to, it's just less than. So that's why we have parentheses on both ends. When you solve these absolute value inequalities, either both sides of the boundaries are going to be exclusive, or both of them are going to be inclusive. So let's look at this situation. So now we're greater than. Remember, we saw up here greater than, in this case, greater than or equal to. It's going to be an or situation. All right, so first, isolate the absolute value. So we get absolute value of x, 4x minus 6, and then we're going to add 1 to both sides, is greater than or equal to 10. So don't try to break it up into two problems like we did here until you've isolated the absolute value. You invariably will get one of the equations wrong if you try to break it into two problems at this stage. So do this first, isolate that by moving the 1 over, add 1 to both sides. Now and only now we should be breaking it up into 2. Now notice this looks a lot like what we just did. That was sort of on purpose. So you can see sort of the similarities and differences that happen here. So we get 4x minus 6 is greater than or equal to 10, or 4x minus 6 is less than or equal to -10. All right, so it's an or because it's greater than. They're both, we had to change the direction of the inequality and the sign of the number in the second one. So let's solve these. So we get 4x is greater than or equal to, we added 6 both sides, so 16, or x is greater than or equal to 4. Sorry, this is kind of running together, the symbols, didn't mean to do that. Greater than or equal to 4, or, and then over here, we're going to add 6 to both sides. We get 4x is less than or equal to -4, and x is less than or equal to -1. So in this case, we're less than -1 or greater than, less than or equal to -1, greater than or equal to 4. So what do we got? We got, might actually be helpful to sort of think about graphing this first. So we have -1 and we have 4. We are a square bracket and shading to the left of -1, square bracket at 4, shading to the right of positive 4. So so now it's much easier to write this in interval notation. Yeah, this is sort of the solution, but we really want you to think about writing this in interval notation. So -infinity up to and including -1, or, and then inclusive of 4 up to positive infinity. And of course, infinity, we always put parentheses on those endpoints. Okay. All right. So let's look then at this next one, E. All right. So in this case, if this is equal to 0, there is no positive and -0. It's impossible. I mean, 0 is neither positive nor negative. So in this one particular case, since the absolute value is isolated already, we can break it into two problems, but it's not really two problems, right? It's 7x plus 28 equals 0, I can't change the sign of 0 because 0 is neither positive nor is it negative. So in this these are like sort of special cases down here that we're looking at. So this is 7x equals negative 28 by subtracting 28 from both sides, and then divide by 7. So x is equal to negative 4. So this one really just has one solution, and that's the special case when it's equal to 0. All right, next one. With these special cases, you really want to, if you want, pause the video and try to solve this, and then we'll discuss it. But generally in class, what I do is have everybody solve this, and I turn everybody loose to it. But if you think about it a little bit, this is an absolute value. This left side, what comes out of it, regardless of what value of x you put in, I'm going to multiply by 6, I'm going to subtract 9. Whether this is positive or negative inside, I'm taking the absolute value. And so this will always, the left-hand side of this inequality will always be positive. Regardless of how big or how small x is, I'm always going to result in a positive number. And that positive number that comes out of this absolute must absolutely be bigger than a negative 2. So this works for any value of x. So we really have, all real numbers, or as an interval, negative infinity to infinity, all real values of x satisfy this inequality. All right. Okay, and then so this is also another special case. Again, if I let you run with it, people would be breaking it into two problems and coming up with solutions. But if you think about it, it takes, if you're a robot, you're just going to do that and probably lose points. But if you stop and think for a minute, again, this left-hand side is always going to be positive. So is it possible that that value that comes out of this, regardless of how big or small x is, this whole thing is positive, is it possible for that to be less than a negative value? And so obviously, no, that's not possible. And so this will be no solution, right? So those two, all three of these are sort of special cases. So be on the lookout for those. If the absolute value is greater than a negative, it's always greater than a negative. So that would be all real numbers. And then absolute value cannot be less than a negative. And so if you're trying to find a value where that would work, there are no x values that would let this absolute value expression be negative. So it's always positive. There's no way it can be less than negative 5. So that would be no solutions. All right, so here is your homework for this section. You can start on it if you have time in class.